Hello, welcome to a recorded lecture of October 4th, Friday, the day before break, and the day the power went out. I'm going to break this up into parts. You can find the summary sheets on D2L, and then you can find the lecture also under lecture on D2L, and then last but not least, you can find the handout for the solubility chart that I'll talk about later. So really what I would like to do is close up chapter 4, and if you're a little nervous about it, we're going to do lots of examples in the next week or so. So don't worry too much, we'll be okay. But really I want to talk about solution chemical reactions, double displacement reactions. And so the first thing I'm going to talk about is acid-base reactions, which you have an acid and a base reacting to form water. And we talked about this on Wednesday, October 2nd, so I'm not going to spend too much time on it. But the important thing is that what we can do is write what we call net ionic equations. And so usually what you're used to seeing and what we just saw is what we call a molecular equation. And the molecular equation is basically has everything to it. So for example, if I just scroll up just a little bit, I'm not trying to, you'll see that this is what we call, up here is what we call the molecular equation. And what people are also interested in is what we call the net ionic equation. And so when you have species that are ionic, or that completely break apart, 100% dissociate, we can actually write what we call the ionic equation, and then all soluble species can be listed as ions. And don't forget, and the important thing is that we leave solids, liquids, and gases as is. And from here, what we can do is get, and this is what the most important part is what we call the net ionic equation. And this net ionic equation is kind of like what is actually happening in the reaction. And so what you'll see is the net ionic equation has no spectator ions. Okay, so I think the best thing to do is to first give you the rules and then actually give an example. Step one is always to write the balanced equation for the reaction, which includes which is the molecular part. And then we're going to identify all strong electrolytes, things that basically 100% dissociate. And then from there, when we break it down, we're going to identify the spectator ions, and then we remove any spectators because they don't really participate in the reaction. So let's take a look. For example, let me just do this example, and then we'll go from there. Write the complete reaction of acetic acid and potassium hydroxide. And so and then write the net ionic equation. So the first thing I'm going to do is to write the complete reaction. So acetic acid is HC2H3O2 aqueous, and potassium hydroxide is KOH. Potassium hydroxide is a strong base, and acetic acid is a weak acid. And so then what we can do is we can do a double displacement. And let's see, I'm gonna be a little cheeky here and use red. And so the cation of this will react with the anion of that, and the cation of this will react with the anion of that. Double displacement. And so what you get is going to be H2O liquid plus K C2H3O2 aqueous. Okay, and then I'm going to check to see if it's balanced. It looks good. So that is the complete. Now, let's write the net ionic. And so the net ionic is what you do is you take everything that will 100% dissociate, which is going to be strong acids, strong bases, and ionic salts. And so we break that down. Acetic acid is a weak acid, so we just leave it as is, okay? And then, but KOH is a strong base, so we do K plus OH minus, AQ, AQ. Now, water is a pure liquid, so we leave pure liquids, solids, and gases alone, and then this salt is going to be K plus aqueous plus C2H3O2 minus aqueous. And so that is the ionic equation. And then the last step is to cancel out any spectator. So spectators are going to be species that are on both sides. So this K plus and this K plus are on the reactant side and the product side. And so what we're going to do is just cancel this out. Cancel this out. Because it's spectating, it's not really doing anything, and it's not really participating. So the net ionic equation is going to look like this. Plus OH minus. And so these are the species that are going to be actually doing something in the reaction. And so this is my net ionic equation. Okay, and so notice what happens is the strong base completely dissociates and the weak acid does not. Okay, so on your summary sheet, there's a question, identify all of these spectator ions in the acid-base reaction below. And so this is already taken apart, so I'll give you a chance to pause it. So if you're going to pause, I would pause right now, and then I will start again. Okay, welcome back. So the spectator ions are going to be ions that don't participate in either side. And so if we take a look here, what you're looking for are ions that exist on both sides. So right here, this Br minus and this Br minus are on the reactant side and the product side. Everything else is on one side, but not both. And so the spectator ions, which we would cross out, is just going to be Br minus. Okay, and so that ends our discussion of acid-base chemistry. And so I'm going to end this video now, and then I'm going to start the next section talking about solubility of ionic compounds. You're going to need that solubility table, which is underneath handouts, or it will be underneath the October 4th lecture. I will see you soon.